Our group name is the Engineers. Our group members are Christian, Jerome, and me, Michael. The title of our project is Bullet Ballistics with Projectile Motion. So in this project, we wanted to test the trajectory of bullets from different guns. Christian chose a 45 caliber out of a Colt 1911. Jerome chose a 308 caliber out of an AR-10 rifle, and I a 17 HMR out of a bolt-action rifle. So in this question, it says if a shooter is trying to figure out the drop of a bullet that is fired from a bolt-action rifle chambered in 17 HMR, if the muzzle velocity of the bullet is 2,650 feet per second, and the shooter is shooting at a 15-degree angle, how far did the bullet travel when the time is 2 seconds? So in our diagram, we can see the shooter is holding the gun 1.5 meters above the ground, and the angle he's holding it at is 15 degrees. So I converted the muzzle velocity from feet per second to meters per second. So the bullet velocity is 807.72 meters per second. Angle is 15 degrees, time is 2 seconds, and it's 1.5 meters above the ground. And to test how far the bullet traveled, we found the initial velocity in the X direction, and then the initial velocity in the Y direction, and then used this equation. So we could see at 2 seconds, the bullet traveled 1,615 meters. And the second part of the question, what is the height of the bullet when the time is 2 seconds? So we use this equation. We put in the height, 1.5 meters, the initial velocity in the Y direction, which is 209 meters per second, and the time, which is 2 seconds, plus 1/2 acceleration times the time squared. And at 2 seconds, the height of the bullet is 399 meters.
All righty. So let me go ahead and do this. All righty. So my name's Christian. I chose a 45 caliber bullet from a Colt 1911. So those unfamiliar, it's a pistol round. It's a pretty good sized pistol round, but still not traveling as fast as, let's say, a rifle. So for my problem, I decided to take a little bit of a different take on it. So I have a shooter that's trying to figure out the drop of a bullet that is fired from his 1911 pistol. If the muzzle velocity of the bullet is 252.98 meters per second, and the shooter is shooting at a 15-degree angle, and it originally takes 1.37 seconds to hit the ground, how far did the bullet travel? So this is also a two-part question. I'm also trying to judge the max height of the bullet. But right now we could just go based off the givens. So we know the initial velocity is 252 or almost 253 meters per second. The initial angle is 15 degrees, and the shooter is shooting at a 1.5 meter distance from the ground. The X initial, we're just going to go ahead and say that his position right now is 0, since that's the position that he's shooting from. And the time is, again, 1.37 seconds. So again, we start with trying to figure out the components of velocity. So the X component and the Y component. And we can go ahead and just plug it straight into this formula for position in X, where we say that the final position of X is equal to the initial position of X plus the velocity component of X times time. So we can go ahead and just plug this all in, and it should give us a distance of 334.7 meters. So that's the distance the bullet traveled until it hit the ground. And then finally, what was the max height of the bullet? So we use this other formula, which gets us the final height, or the final distance in the Y component direction of the bullet's travel path. So again, we start with the final position of Y equals to the initial position of Y, which here would be 1.5 meters, because that's where he's starting from. Then the Y component of velocity times time, plus 1/2 times the acceleration due to gravity times time squared. So We do have to be careful because since he is shooting up, gravity is acting in a downward motion, so that acceleration of gravity will actually be negative. So in the end, the max height of the bullet's travel path should be 81.995 meters, or almost 82 meters. So yeah, that's that. And was there anything else that we needed?
I think we're okay.
Alrighty, we do have one more member we're going to do a separate video with him later. He just couldn't make it right now. So again, this is for the ballistics of a bullet with projectile motion. So yeah.